Welcome back to my channel. If you like my videos, do subscribe my channels. I'm Teacher Todd. Today, I'm going to show on how to do conversions between solutions, concentrations, expressions using this chili sauce.
Based on the nutritional facts label, there are 960 mg of sodium ion in 100 g of chili sauce. The 960 mg can also be converted to 0.96 g, since 1 gram is equals to 1000 mg. In my solutions, concentrations, expressions video, I have explained that in a solutions, HCl solutions, if there are 36 grams of HCl in 100 grams of solutions, basically it means that there are 36% of HCl by mass in the solutions. So 960 mg of sodium ion in 100 grams of chili sauce solutions also means that there is 0.96% sodium ion by mass in the chili solutions. So to do conversions between solutions, concentrations, expressions, basically there are 6 steps to follow through. So step number 1 is to construct a table with column for solute, solvent and solutions, and rows for volume, mass and number of mole. For step number 2, we need to make assumptions according to the definitions of the solutions, concentrations, expressions given. For step number 3, we can fill in the table. So the table is the table that we construct in step 1 based on the assumptions that we made in step 2. For step number 4, we can write out the formula for the solutions, concentrations, expressions that we want to find and compare it with the information that we have listed out in step number 3. Step number 5, we can compare the information that we listed in the table with the formula and do the unit conversions as required. And in step number 6, we just need to substitute what we have converted in step number 5 into the formula to get the final answer. If you watch my previous video on solutions, concentrations, calculations, you can see that step number 3 until number 6 basically are the 4 steps we need to follow through if we want to calculate a solutions, concentrations, expressions based on the information given in the questions. Based on the nutritional facts label on the chili sauce, there are 0.96% of sodium ion by mass. This 0.96% sodium ion by mass is refers to percentage by mass of sodium ion in the chili sauce solution. So the first conversions I would like to discuss is to convert the percentage by mass of sodium ion to the mole fractions. The second conversions I'm going to show you is on how to convert the percentage by mass of sodium ion to molality of sodium ion in the solution. How to convert percentage by mass to mole fractions? There are 6 steps to follow through. Step number 1 is to construct a table with solute, solvent and solutions columns and rows to fill in volume, mass and number of moles. We can put a dash at the row for number of moles and solutions column because there's no such thing as number of moles of solution. In step 2, we can make an assumption according to definitions based on the information given. So in these examples, the information given is 0.96% sodium ion by mass. This is percentage by mass, solutions, concentrations, expression, and based on the definitions of percentage by mass, it basically means that there are 0.96 grams of sodium ion solute in 100 grams of chili sauce solutions. Based on this definition, we can write our assumption whereby the mass of solutions is 100 grams So when mass of solutions is 100 gram, then the mass of solute will be 0.96 gram. In step number 3, we fill in the table in step 1 with the information that we have in step 2. In step 2, we have two informations, the mass of solution and the mass of solute. So we can put these two informations into the table first. Based on these two informations, we can also calculate the mass of solvent. When we make the solutions, basically we need to have solute and solvent mixed together to form a homogeneous solutions. Hence, to find the mass of solvent here, we just need to subtract the mass of solute from the mass of solution. Then we can get our mass of solvent as 99.04 gram. Then number 4 is to write out the formula that we are looking for. In these examples, we are looking for mole fractions. So in step number 4, we write down the formula for mole fraction, whereby mole fractions is equals to moles of a component divided with total moles of all components. And the moles of a component here is referred to number of moles of a solute, and our solute here is sodium ion. And the total moles of all components refer to sum of number of moles of solute with the number of moles of solvent. Then in step number 5, we do comparison with information that we have in step 3 with the formula in step 4. So in step 3, the information that we have is mass of solute. But based on the formula of mole fractions, what we need is moles of solute. So means that in step number 5, the first conversions that we need to do is to convert mass of solute to moles of solute. So how to find moles of solute? So we just need to use mass of solute 0.96 gram divide with the molar mass of sodium ion 23 gram per mole to give us moles of solute. The second conversions that we need to do in step number 5 is to find moles of solvent. Moles of solvent. So how to find moles of solvent? Again, the mass of solvent. So mass of solvent divide with molar mass of solvent. So our solvent here is aqueous based chili sauce. So the solvent is water, H2O. So the molar mass of H2O is 18 gram per mole. So the mass of solvent 99.04 gram divide with 18 gram per mole to give us moles of solvent. Then in step number 6, we just need to substitute whatever that we have converted in step number 5 into the formula to get the final answer. So in step number 5, we already have moles of solute. So we just need to substitute it into the formula. And also moles of solvent. So substitute it into the formula. And the 7.529 times 10 to the power of negative 3, that is mole fractions of sodium ion in the chili sauce solutions. So I will show you another examples on how to convert between solutions concentrations expressions. Again, to do this, 6 steps to follow through. So step number 1, construct a table with solute, solvent and solutions columns and volume, mass and number of moles rows, and put a dash on the number of moles of solution. And in step number 2, we made an assumptions according to the definition based on the information given. So in these examples, again, the 0.96% sodium ion by mass is percentage by mass, and it means that they are 0.96 gram of sodium ion solute in 100 gram of solutions. So based on these definitions, we can make an assumption that the mass of solutions is 100 gram, and when the mass of solutions is 100 gram, so the mass of solute will be 0.96 gram. In step number 3, we fill in the table using the information in step 2 into the table in step number 1. So based on the assumptions in step 2, we have mass of solutions 100 gram and the mass of solute 0.96 gram. And then from this, we can calculate the mass of solvent by subtracting mass of solute from the mass of solution, give us the mass of solvent 99.04 gram. Step number 4 is to write down the formula of solutions, concentrations, expressions that you are looking for. Like for these examples, we are looking for molality. So in step number 4, we write down the formula for molality. So molality is equal to moles of solute divided with the mass of solvent in kg. So in step number 5, we compare what we have in step number 3 with the formula in step number 4 and do some conversions. So in step number 3, we have mass of solute, and in step number 4, we want moles of solute. So means that the first conversions that we need to do in step number 5 is to convert mass of solute to moles of solute. So how to find moles of solute? So the mass of solute divided with the molar mass for sodium ion is 23 gram per mole to give us the moles of solute. And the second conversions that we need to do is to convert the mass of solvent from gram to kilogram. So how to do these conversions is by dividing the mass of solvent 99.04 gram with 1000 gram per kilogram to give us the mass of solvent in kilogram. Why we divide it by 1000? It is because 1 kilogram is equal to 1000 grams. Step number 6, we just substitute what we have converted in step number 5 into the formula to get the final answer. So in step number 5, we have moles of solute. We just need to substitute the moles of solute into the formula, and also the mass of solvent in kg, substitute it into the formula of molality. Then we get the final answer 0.4214 molar as the molality of sodium ion in the chili sauce solution. To convert between molality and molarity, the density of solutions is needed. Density of solutions is equal to mass of solutions divided with volume of solutions. However, one thing you need to take note is density is not one of the solution's concentrations expressions. The density formula can vary. Hence, if you have been given density of solute, then the formula will be density of solute equals to mass of solute divided with volume of solute. If you have been given density of solvent, then the formula will be density of solvent equal to mass of solvent divided with the volume of solvent. I'm still using the same examples as previous, but for this, we are going to calculate molarity of sodium ion in the chili sauce. As I mentioned before, if we want to do solutions, concentrations, expressions, conversions to molarity, we need another term called density. So I have Googled and then found the density of chili sauce solutions is about 1.15 gram per ml. So I'm going to use 1.15 gram per ml as the density of chili sauce solutions for this calculation. Again, to do conversions between solutions, concentrations, expressions, there are 6 steps to follow through. Step number 1, construct a table with solute, solvent and solutions columns and rows to fill in volume, mass and number of moles. Step number 2, we make an assumption according to definition based on the solutions, concentrations, expressions given. So in these questions, we have been given 0.96% sodium ion by mass, which also means that the mass of solutions is 100 gram and the mass of solute is 0.96 gram. In step number 3, we fill in all the information that we have in step number 2 and put it into the table. So we have 100 gram of mass of solution, so we can fill it in, and also the mass of solute 0.96 gram. And then we can calculate mass of solvent by subtracting the mass of solute from the mass of solutions. And because we have been given the density of solutions term, And since we have the mass of solutions, we can also calculate volume of solutions. So by putting the density 1.15 gram per ml and also the mass of solutions 100 gram into the density of solutions formula, we can calculate what is the volume of solutions. Step number 4 is to write out the formula for solutions concentrations expressions that we are looking for. In these examples, we want to look for molarity. So in step number 4, we write out the formula for molarity. Molarity is equals to moles of solute divided with volume of solutions in liter. In step number 5, we need to compare the information that we have in step number 3 with the formula in step number 4. In step number 3, we have mass of solute, but in the formula, we want moles of solute. So means that in step 5, the first conversions that we are going to do is to convert the mass of solute to moles of solute. So how to find moles of solute? The mass of solute divide with the molar mass of solute. And how to find the volume of solutions? So in step number 3, we have volume of solution in milliliter. But in the molarity formula, we want the volume of solutions in liter. So how to convert milliliter to liter? So basically, we just need to divide the volume of solutions in milliliter with 1000 to get the volume of solutions in liter. Step number 6 is to substitute what we have converted in step number 5 into the formula to get the final answer. So we just need to substitute the moles of solute into the molarity formula and also the volume of solutions in liter into the molarity formula to get the final answer, 0.48 molar sodium ion in the chili sauce solutions.